I chose to do my presentation on Robert T. Jones. Robert's early life. Robert T. Jones was born on May 28th of 1910 in the town of Macon, Missouri. Robert had an interest in aviation from a very young age and built many model airplanes as well as rubber band-powered gliders. Robert's math teacher, Iva Z. Butler, introduced Robert to an interest in mathematics, teaching him concepts from exponents to trigonometry. After Charles Lindbergh completed his nonstop transatlantic flight in 1927, aeronautical interest in the United States blossomed, which allowed Robert to more readily access aviation knowledge from magazines such as Aviation and Aero Digest. Robert attended the University of Missouri studying engineering, but dropped out after only 1 year due to a lack of aeronautical courses being offered there. In 1919, Robert was hired as the only engineer at the Nicholas Beasley Airplane Company Incorporated. Later, when Thomas Kirkup, an English certified engineer, was hired, Robert learned how to perform stress calculations which were necessary for his work. During the Great Depression, however, the Nicholas Beasley Airplane Company was forced to shut down, which put Robert out of work. Robert soon found himself in Washington, D.C., where he met his congressman, who helped him to get a job as an elevator operator nearby. With his newly found job security, Robert continued his mathematical studies. Robert was also able to attend classes in aerodynamics taught by Max Monk, a German-American scientist who had previously worked for NASA, the precursor to NASA, before he left NACA to teach at Washington's Catholic University. While Robert was doing some research at the Library of Congress, he made the acquaintance of Dr. Albert F. Zahm, a physicist who managed the aeronautics collections in the Library of Congress. Zahm was actually the person who was able to give Robert a contact that would help him to get a job at NACA. As a result, Jones obtained a 9-month temporary appointment as a junior scientific aide at the Langley Aeronautical Laboratory for NACA. After the temporary appointment ended, Jones's supervisors gave him a permanent job there. Robert's initial work at NACA or NASA. One of the first projects that Jones worked on at NACA was an airplane with a more simplified two-control operation, meaning the roll and yaw controls were connected with separate pitch controls. This principle was first implemented in the Erco Ercoupe. After this project ended, Jones went on to research delta wings using many techniques such as wind tunnel testing. He found that delta wings were highly efficient for supersonic flight due to the wings of the airplane remaining within the Mach cone, which resulted in lower drag and higher lift produced due to the supersonic air the wing would flow through. Oblique wing aircraft. The first American supersonic aircraft, the Bell X-1, had no wing sweep due to many American scientists not accepting the benefits of swept wings at the time. When German scientific documents became available to him, Robert T. Jones became enamored with the science of delta wing aircraft for supersonic flight after World War II. Both American and German scientists independently developed the concept of variable sweep wing aircraft, likely due to their research of the same scientific papers before and after the war. Robert, however, thought that instead of moving two wings independently, aircraft with variable sweep wings should use a single pivot point to change their sweep angle, one wing to the front and one wing to the back. This approach was promising, but had some major flaws, such as the tendency of the aircraft to behave unpredictably while maneuvering. These are the sources I used for this presentation.